Hello, this is Math with Beth, and today we are going to do limits, but finding them algebraically. So there's one theorem we can use for this. That's the limits of rational functions. For any rational function f with a in the domain of f, the limit as x approaches a of f of x equals f of a. That's very wordy, but what all that really means is if you're trying to find the limit at a certain number, and that number is in the domain of the graph, meaning there's not a hole there, there's not an asymptote there, there's nothing weird going on at that number, then the limit is the same as the actual value at that point. So algebraically, what that means is when you're given an equation and you're asked to find a limit at a certain number, the first thing you should do is just plug that number in and see what you get. If you get a normal number, then that's your answer. If you get something that's undefined, then you're going to have to be more creative with your method. So let's try it for this one. So if I were to plug in zeros to all of the x's, I would get 0 squared plus 3 times 0 plus 3, which means I would just get the square root of 3, and that is totally fine. So that is my limit. And we know that 0 is okay to plug into here because it's not going to make it a negative, right? So for this one, if I plug in 1 for all the x's, let's see what we get. So we would get 2 times 1 plus 3 times 1 minus 6. So we would get 5 minus 6, which is negative 1. So again, that is fine. And one more. So here's one where there could be an issue because we have an x in the denominator. So for instance, if they were asking me to find the limit when x approaches 1, do you see why that would be a problem? But since it's negative 2, then I can plug that in and I would get 0 on top, which a lot of people kind of panic when they get a 0, but a 0 on top and a number on the bottom is totally fine. So that just means our final answer here would be 0. Now, you do need to pay attention to how your instructors teach this, though, because some instructors are picky on the notation and might make you be very careful about writing the limit as x approaches negative 2 of this stuff equals the limit as x approaches negative 2 of this step equals. Like they might be picky on you writing the limit over and over again. So definitely pay attention to how your specific instructors want you to write things. All right, so first time we have an issue, one of the methods that might help us is factoring. So does everyone hopefully see that if we were to plug a 2 into this problem, we would get 0 on top, which is fine, but we would also get 0 in the bottom, and that's a problem. 0 in the bottom of a fraction means it's undefined. So this is an issue. But if we factor, and we can factor the top because it's a difference of squares, so it becomes x plus 2x minus 2. Then we can cross out the x minus 2's. So our final problem now becomes x plus 2. And now that we've reduced it, we've kind of eliminated the issue. So now let's try again to plug into. So again, I'm not being super careful on my notations. I'm just trying to teach you how to do it. So again, disclaimer, be careful on how your instructors want you to write the notation. But this is the general idea. If there's an issue such as this, try factoring because after you reduce, you might be fine. The next issue that might come out is same type of thing. If I plug into a 13, it would make the bottom 0, but this time there's nothing to factor. So another method to help reduce this nicely is rationalizing the numerator, which just means there happens to be a square root in the numerator. So I'm going to do a trick that will help me get rid of that. So the trick is multiplying by the same thing you see that has the square root, except change the middle sign. So in this case, I changed the square root of x minus 4 minus 3 to the square root of x minus 4 plus 3. So I'm going to be multiplying that all on top. And of course, if I randomly multiply on the top, I have to multiply the same thing on the bottom. So what does that all give me? Well, a square root of anything times a square root of the same thing just frees what's inside that square root. Like the square root of 2, square root of 2 would just be 2. So same idea here. Now the square root of this times the 3 would give us this. Negative 3 times that square root would give us this. So hopefully you see they're going to cancel. And then finally I have the negative 3 and the 3. So I'm just foiling this. On the bottom though, I'm not going to waste time foiling because I'm hoping something will nicely wipe out eventually, or I'll just be able to plug in my number at some point. So this is where we are right now. These wipe out. So I end up with x minus 13 on top, which is convenient because I have an x minus 13 on the bottom. So good thing I didn't waste my time foiling all that out, because now I can cross out the x minus 13 on the top and bottom. Now, when you have a fraction and everything on the top wipes out, remember there is still a 1 there, because really when we say things wipe out, they're becoming 1, because anything divided by itself is 1. So this is my final problem after doing the trick to reduce. So now I'll try to be a little better with my notation. So now to find the limit here, I'm going to go ahead and plug in my 13. So I get 1 over the square root of 9 plus 3. Square root of 9 is really 3. So I get 1 over 3 plus 3, which is 6. So that is our second strategy, rationalizing the numerator when there is a square root in the numerator. Having trouble saying that word. All right, and our last algebraic trick to kind of reduce things that aren't nice is this one. So again, this would be an issue because there's an x alone in the bottom and I'm plugging in 0. If I was plugging in 1, would this be a problem? Nope. So it just happens to be a problem because I'm plugging in 0, and that would make 0 in the bottom. So the strategy here is simplifying complex fractions, which basically means we have fractions inside of fractions, and let's make this as simple as we can. So the strategy is, if there's 2 fractions being added or subtracted, let's combine those, which is going to mean getting a common denominator. And then eventually we're going to do dividing with our fractions by doing the trick of keep, change, flip. So step 1, if I want to add or subtract the things on top, I need a common denominator. So I need this fraction to have the 6 that one has, because unfortunately I can't count this as being the same 6 because this is technically an x plus 6, so it's different. And this fraction needs the x plus 6. So that turns this into 6 over this minus x plus 6 over this. And now they match to be able to combine that. I just need to be careful because that negative is going to need to be applied to the x and the 6. Right? Because it's like 6 minus all of this. So it turns into 6 minus x minus 6 all over the common denominator. And then don't forget, that's all over x, which we're going to deal with in a moment. So this turns into 6 minus 6. So just negative x over 6 times x plus 6 all over x. So now I've made the top nicer by combining the 2 separate fractions into 1 fraction. But now I can go even further by thinking of this as this top fraction being divided by this bottom one. So if you want, you can consider that x over 1. And the way we divide is keep, change, flip. So we keep the top fraction the same. We change the problem into a multiplication problem. So that's the change. And then we flip the bottom fraction. So instead of x over 1, it turns into 1 over x. So now these x's cross out, and we have negative 1 over 6 times x plus 6. So now if we want to take the limit we would plug in the 0, and that would give us negative 1 over 6 times 0 plus 6. So negative 1 over 36. So this one definitely involves a lot of algebra skills as far as reducing rational expressions, getting common denominators, and remembering that you can always divide by switching it to keep, change, flip. Hopefully that helped, and I will be doing some more videos on limits really soon.